Hi, everyone. My name is Viviana Conti, Application Development Engineer for NatureWorks. I'm really excited today to show you a presentation on our bio-oriented PLA developments, focusing on eliminating obstacles during film processing and improving film production efficiency. Our focus today is compostable flexible film and the evolution of this BiAx film in the new European environments. So we will go through packaging waste regulation, the impact on the future of flexible packaging in Europe, performance with bio-oriented PLA film that become a valid alternative to incumbent, and collaboration, how transversal efforts can change the industry, and really show you a case study. Our focus today. So our packaging waste regulation is impacting and change the future of compostable BiAx-oriented PLA. So in the flexible packaging is a combination, as we know, on different film and different technology that are using to do this film cast-oriented blown BiAx. Our focus today is really compostable BiAx film. Packaging waste regulation and bio-oriented PLA. So BiAx-oriented film is a flexible film for packaging obtained by stretching the polymer in both longitudinal and transversal directions. So if we, and I really like this slide because it shows you clearly that if we see today current application on bio-oriented PLA today, this image shows you other opportunities that are related to packaging waste regulation, like bio-oriented PLA for small format packaging, candy, creamers, jam, spreadable and soluble products, bio-oriented PLA for condiments like ketchup, mayonnaise, oil, vinegar, or bio-oriented PLA for lidding for coffee capsules. But let's go in more details on these applications and the impact that this application will have on the packaging waste regulation. So this regulation will ban single-use plastic packaging for condiments, preserves, sauces, coffee creamer, sugar, and seasoning in the HoReCa sector dine-in. So the derogation from the ban, if compostable, so bio-oriented PLA will be and can be a key elements of this multi-layer structures. Talking about lidding for small portion packaging. So the reason opportunities for bio-oriented PLA-based lid to support expected growth for compostable small rigid container. You see here a commercial product already in the market. The bio-oriented PLA, it's part of the lidding. And another example, an important application is coffee capsules. There is a specific regulation on single-serve beverage to allow industrial compostable capsules and lidding. And also here, bio-oriented PLA become a key lidding element. So now, when we look today, bio-oriented PLA film in use has been used by the industry for some years now. So, and you can see here the benefits of the film. So from industrial compostable stiffness, transparency, printability, sealing, bio-based, aroma barrier, twist performances, low shrinkage. But there are still room for improvements, basically on economics, improve barriers. Because as I show you before in the slide before, barriers, water barrier, oxygen barrier are really key. And a quicker degradation. So talking about collaboration, it's really key, especially in this type of application that we are talking always about systems. So it's key to really highlight the collaboration that we have in place. So Bruckner Group is really the #1 Maschinenbau, leader manufacturer of BiAx film stretching line in the world. And we started really to collaborate with them to be sure that the formulation can run properly and can run at industrial scale. The second partner, Sukano. Sukano is a family-owned global specialist for tailor-made additive and color masterbatch in polyesters like PLA, PHA, PBSA. So why was really key to have this collaboration in place? Sukano is producing anti-block masterbatch for bi-oriented PLA, reducing the coefficient of friction. And these films have much less tendency to stick during winding and unwinding and can easily be processed during secondary processing step. So the benefit of the products made by Sukano in combination with our NGO PLA is, of course, have benefit in easy processing and good printability, compatibility with our PLA resin, transparency, and good barrier performances. So all this to say what? That collaboration are key to expand the field of application of bi-oriented films, but also to reduce time to market. There are many steps before going to the shelf. So, and thanks to this great collaboration of NatureWorks, Bruckner, and Sukano, we can go from a lab validation through all the steps, or the most important steps, for an industrialization. So BiAx film production at Bruckner, metallization and lamination at industrial scale, alloys, matte barrier coatings, and then lamination again on bigger scale, and then filling. So, but let's go on the core of this presentation. When we talk about performance, I think that this is really one of the slides, or probably is the most important slide of the entire presentation. So here there is a comparison of BiAx stretch ratio comparison between polyester, PLA, polypropylene. So when we see the new developments made by NatureWorks, the new NGO grade can have a bigger or a higher stretch ratio in the transversal direction. And what does it mean? This means really efficiency and improve efficiency during processing. So one of the most important steps when we are producing bi-oriented PLA, it's during processing. These lines are very big. These lines have really high output. So it's really key trying to reduce the impact of the cost during processing. So improve basically the efficiency during processing is key. And with having a higher stretch ratio, so we have increased the total yield by 25% and the output is increased by 56% if we compare similar speed line with different stretch ratio, with a standard stretch ratio of PLA of 4.5 versus a 7 with a new formulation. Improved performances, barrier properties. This is another key slide. So today, bi-oriented PLA film has very low barrier properties. And when we look to coffee capsules business, to small format packaging application, hot foods, every of those food application needs barrier, needs a very good water barrier and a very good oxygen barrier. So the focus during this development was really to moving towards ultra high barrier results. So recent developments confirm barrier improvement in film with NGO bi-oriented PLA substrate. And improve performances with potential for quicker degradation. So our new NGO grade shows an improved potential to increase and to have a faster hydrolyze than standard PLA grade, And there is opportunities really to blend the new Ingeo PLA with slower hydrolyzing PLA or other slower hydrolyzing polyester in order to increase the hydrolysis rate of the resulting Ingeo grade. And with that, I really want to thank you, everyone. Thanks for your time, and stay tuned. You can find us on LinkedIn or on website. Thanks a lot.